Hi, kiddos. So this is for Module 2.3, solving for a variable. And again, a variable is basically any letter, x, t, something to represent the unknown quantity. So our essential question is, how do you rewrite formulas and literal equations? So let's take a look. Our shortest answer is use the properties of equality to undo operations to isolate the variable or a variable. Again, properties of equality, right? You have the addition, right? Property of equality. We have the subtraction, property of equality. I'm going to use these parentheses to represent properties of equality. We have multiplication, uh, property of equality. All right, and then we have division, property of equality. So again, what you do to one side, do to the other. All right, so that's kind of the idea of properties of equality. All right, so rearranging mathematical formulas. So literal equations, all right, are quite literally are equations that contain two or more variables. So, for example, the volume equation for a prism, okay, is going to be the volume equals the length times the width times the height. That is a literal equation. Notice how there's a lot of variables. There's L, right, which represents your length. The width is W, and H is the height. All right, and we even have V representing the volume for whatever it is. Now, rearranging means that we're going to basically get a certain letter isolated or all by itself on one of our sides. Now, in this situation, we're going to go ahead and solve for L, our length. Now, notice how L is really multiplying with the W and H, and vice versa. The W is multiplying to L, as is the H. So, what is the opposite of multiplying? Well, how do we get rid of W and H, right? We want them to get away from L. So how do we take them away? Well, W is multiplying, right? So what's the opposite of multiplying by W? Divide, right? But just remember what you do to one side and do the other. So that is the division property of equality. So once you do that, you'll have the volume divided by your width. Sorry, that's a terrible W. All right, equaling the length. And what was left? The height? We didn't touch the height. The height's still multiplying, right? Yeah. Now, how do you get rid of a multiplying h? Well, what's the opposite of multiply? Divide. Okay. So again, we did the division property here. So that was the division property of equality, as is right here. We did it again. All right. Now, remember what we do to one side, do the other. So we're going to divide both sides by h as well. And again, if you do this, you should be removing, um, certain parts on the one side that you care about. In this case, we care about the right-hand side because length is there. All right, so in the end, length is all going to be by himself with volume over here, and volume is going to be divided by the width and the height. And we're going to go ahead and apply the symmetric property, which is really just spinning the literal equation around. All right, so when then we read it, it's really the length equals the volume divided by the width. So that's one way of doing it. So that, again, that's a symmetric property where they spin like that. Symmetric property. And you will see that a lot, especially in geometry next year. Okay. All right, so that's one example. Now, why do we need to know that in the real world? If somebody's selling you a fish tank, who knows? All right, it could be a fish tank, a water tank, a gas tank. You never know. They'll tell you, oh, there's a certain amount of volume for this, and maybe your friend measures, the width and the height. and totally forgot to measure the length. And you're like, well, I have the volume, I have the width, I got the height. So because you already know how to isolate for your length, you can just apply the formula that you rewrote to solve for your length. That way you can get your measurement going that way. So just be aware, sometimes you can move around formulas depending on what you need for that given situation. All right, so for example, the density formula, density equals the mass, which is m, over the volume. So isolate V. Well, what is V doing? V is dividing at the moment. So what's the opposite? So what is the opposite? Oh, thank you, Ben, for making my life so much more interesting. Okay. What is the opposite, right, of dividing? That's the question. And yes, apparently I forgot my I right there. There we go. And hopefully you realize, oh, it's multiplication, right? Like, hopefully you thought multiplication. All right, so again, how to get rid of a dividing v? Multiply by a v. But remember, what you do to one side, we have to do to the other. All right, so now we're getting v by himself. In reality, we're really just moving v over to the left-hand side also. So these v's will cancel out. You're going to have v times d, right? Because you multiply the v to both sides. What you do to one side, do to the other, equaling the mass. But remember, we want to get v all by himself, right? But who's with v now? Ah, d, right? Now, what is d doing, right? D is multiplying. So what's the opposite of multiplying by d? Divide. Just remember, what you do to one side, do to the other. You should cancel out the variables you want, and then all that's left is v equaling the mass divided by your density. And there's questions like this, especially in geometry. So this is very important for next year. In geometry, we talk about mass. So please remember this. And with mass, sometimes they don't give you the mass, so you have to solve for mass. Sometimes they give you the mass and the density and tell you what's the volume. So you have to know how to rewrite and rearrange literal equations. All right, so this would be your final answer. So again, we're doing a lot of multiplication property, right, and division property of equality to figure out how to get V isolated. All right, rearranging literal equations. So in applications, sometimes whatever variable you're looking for isn't really isolated already. So we're going to go ahead and see an example. So looks like we have find the number of years. Okay, so that's time. But notice how time is not all by himself, right? So we're solving for t. Okay. So whenever you see years, months, hours, we're talking about time. Okay. Otherwise noted as t. Now, used in the calculation of a $1,000 loan at an interest of 5%. Okay, with the interest totaling 600 bucks. All right, so your interest was 600 bucks. So your interest is I. Okay, your rate is 5%, and your loan, otherwise known as your principal amount, is P. All right, principal is the amount, the original amount of your loan. So when you guys get credit cards, be careful. Your principal, it's like, oh, it's $1,000. It's no, I could pay that off quick. Well, 5% at rate, costing 600 bucks after the end of it. Well, shoot, that's 1,600 bucks, man. That's $600 more than you thought. So be careful with loans, okay, or credit cards. They can do that to you. All right, so let's solve for t. Let's get t all by himself. Now, who is with t? P and r, right? Now, how do we move p and r away from t? What is p and r doing to t? They're both multiplying, right? So how do you get rid of a multiplying p? Divide, right? So that's division property of equality. All right, so when you get that, you'll have interest over your principal equaling r times t still. Now, how do you get rid of the r? Again, the r is multiplying to t, right? R times t. So, division property again. Just remember what you do to one side, got to do the other. And you should be seeing, if you're doing this right, you should be getting them to cancel out on the side that you want to get isolated, right? With the only variable that you care about. And that again is division property of equality. All right, so when you do this, t is finally by himself on the right-hand side. Your interest is being divided by both your principal and your rate. And we could always apply the symmetric property to where we just, again, spin it around. Your principal times your rate. And it looks like, again, your interest was 600 bucks, right? Your principal was 1,000. And your rate, your percentage, could be represented as this, okay? So let's try to figure this out. We got 1,000 times 5%. So remember when we did stats, right? 5% is really 0.05. So that's kind of conversation about frequency. So that's still kind of a background piece of knowledge you need to realize. All right, so let's try it. 600 divided by 1,000 times 0.05. Boom, 12. So, dang, it's an old loan. Took you 12 years to accumulate that much interest. So, the moral of the story is, kiddos, the sooner you pay off your loans, the better. Otherwise, that number, 600, can get a lot bigger. All right. A lot of people pay twice the amount they originally get loans for sometimes. So, be careful. All right. So, example 4, determine the interest rate for a loan, a $2,000 loan. So, that's principal, right? That would be paid off in 4 years. Okay, so we got time this time. They gave us time with an interest totaling 640 bucks. Okay, that's a little bit more than last time, but our loan is a little bit more, so okay, that's not too bad. All right, now we have to find the interest rate. All right, so you're trying to figure out, okay, did my bank lie to me? Because that's a lot of money. So they promised me a certain rate. Well, let's go ahead and isolate the variable we care about. So again, we're using the original formula. Interest equals P times R times T. Right? But this time we care about R. Okay? So how do we get rid of a multiplying? Who else is with R, right? P and T. What is P and T both doing to R? They're multiplying. So what's the opposite of multiplying by P and what's opposite of multiplying by T? And hopefully you realize you can just divide, right? Now I'm doing 2 steps in one, so be aware. The T's cancel out, the P's cancel out. R is all by himself. So you're really just using the division property to isolate the one variable you need to look for, which is your rate. All right, so you should have your rate as interest divided by your principal times your time. Symmetric property, you can flip it if you want. So again, that was a symmetric property of equality. All right, and let's go ahead and use the formula. We had what? We had an interest of 640 bucks. Being divided by your principal was 2,000 bucks. Times your time, which was 4 years. Let's go ahead and do that in a calculator real quick. So 640 divided by, what was that, 8,000, right? 2,000 times 4. And you have 0.08. And again, just like with relative frequency, move the decimal 2 places, and that is 8% interest rate. Some companies, some bank companies, they say, "Oh, you're at 0% interest." And if you read at the very small fine print, they say it's only good for like I forgot like 6 months, and then normal fees start applying. So if you don't pay this thing off, and it's been 4 years, and next thing you know, you're like, "Wait, my interest is $640, but I thought I had 0% interest rate in the advertisement." And then this is probably the moment as an adult you realize, I should have read the fine print. Okay. Banks are good, but be careful. Read the fine print. All right, your turn number one. So here is your formula. Okay. And now you want to solve the equation for the slope for your m. So the goal is to get m all by himself. Now, who is with m? You have x. What is x doing to m, right? How do you get rid of that, right? What is this b doing, to the side here? All right, so how do you get rid of a b? So start here first. Start with your constant term. How do you get rid of the plus b? And remember properties of equality. Then try to figure out how you can get rid of a multiplying x. All right. So here's your homework, page 70 through 71, numbers 1 through 5, 7 through 8, and 11 through 13. If you guys have any questions or concern, feel free to see me. And yeah, William Defoe. Horrifying. Thank you, William.